I scraped jobs off of startup.jobs by reverse engineering their search API, and I made it into an Apify actor and an npm package, which is now being used in JobOps as an extractor source. Here is every single mistake I made in implementing this package for this web scraper. My initial approach to figuring something out about how to reverse engineer this website was to make a browser-based approach where a bot comes in and clicks all of these buttons and gets the results using HTML. But that has a few problems, as we are now going to find out. Okay, so I'll talk about the browser-based CamoFox version of this implementation. It goes to the basic page first, gets the Algolia cookies and the Cloudflare cookies that are required to pass the browser test, and then spawns in a whole bunch of browsers, as we can see, that result in a lot of performance being used on my M4 Pro. And this is basically unusable on stuff like Apify because of performance constraints. The first real step was figuring out how to reverse engineer this search API. I was looking for how this search works, and I found out that it says very obviously that it's on Algolia search. Okay, sure. We search, so we find up search. There we go, and then we search for Algolia. We're gonna skip the HTML part and the minified part. The first thing that pops up other than this is current.algolia.api search, and we see these three different things here that are coming from the current object, which in Rails is like a default thing from what I've heard. So what I do is I go in here, I paste this in, console log them out. I just get these keys out right away, right? So I can now make requests as Algolia search. I soon realized, however, that I couldn't actually send requests directly to this URL because it results in a just a moment, which is a Cloudflare WAF check, which I cannot pass with any regular fetch or curl requests. So I needed a workaround. This fix came in the form of a library called wreq-js, which is an amazing library. It's really niche for now, and it emulates the TLS handshake that browsers make with the server, which usually helps us avoid the Cloudflare bans entirely because Cloudflare sees us as a regular browser instead of as a one-time short-lived fetch request. I've made a script here that compares the fetch version versus the wreq version. So we can run this and we can see that the plain fetch results in a 403 forbidden, whereas the wreq-js approach that impersonates Chrome 142 on macOS, see here, returns a 200, which means that that passes the Cloudflare checks. Moving even further away from the browser-based approach, to completely eliminate the browser entirely, even the first request where we get the Cloudflare tokens and cookies and the Algolia cookies, we can completely automate or make into a curl request using the TLS-enabled wreq-js sessions. So we make a new session using Chrome 136, we retry a few times, we go to the basic homepage, and we try a few times. If we get a cookie, we just send that to a parser, which we have here, and that just saves the debug cookies that we can reuse later for every other request, so that we already have the cookies and the Algolia data that we need to send with each request so that we can automate the process. I'm going to show off the startup scraper, like startup job scraper, working in Apify. So we have the search query, we have the requested count, do we want to enrich or not, and then this is the specific latitude and longitude of where you want it to be circled around. This is in Preston in Lancashire, where I'm closely based. So we start, we see the CPU usage and stuff going up. It's going to pull down the container, which is almost certainly the longest part of the whole thing. And we will see that there is no massive spikes in CPU or memory usage, unlike there used to be when the browser version of this used to be run. When the browser was run, this is why I had to increase the memory limit as well. We used to run into the browser limit pretty much immediately. The CPU would be pegged at 100% and it wouldn't go beyond maybe 5 or 6 jobs being scraped because it just couldn't spawn that many browsers in. You'll see this, we have this many done, pretty much instantaneously. It's done all of these and it saved them. Succeeded in the dataset, boom, 35 seconds. Most of it, as you saw, was getting the container off of the container registry that they have. We can see what's in the storage. Let's see. Nope, this one. Preview. There we go. So you got software engineering positions that are very close to Preston. In the same vein, the same package, so the npm package is used in job ops. So this is the job ops startup jobs extractor. And in here, we have the exact same function that we made in the package that is being used as is for every search term and every run location, right? You can see scrape startup jobs with Algolia. That comes directly from the startup jobs module itself. The Apify actor and the npm package are now online. You can see them in the description. You can also check out job ops if you're using job ops starting from version 0.2.0. This is enabled as a scraper source there. You can use job ops to import jobs into job ops and use that in your job ops workflow so that you can track your applications, you can generate custom tailored CVs, and all sorts of other things that job ops has to offer. If you want to see those, check out the video in one of these cards here.